Hello guys, today we are starting the chapter Definite Integration. So today is part 1 of the Definite Integration series. Let us understand the concept of definite integration. Remember, if you integrate suppose f of x and you get a g of x plus c, then if you have integration of a to b of f of x, then that will become g of x just like in the earlier case, like in indefinite integration. But we then write a and b on the right side like this. And what do we do with that? We substitute b in place of x, then we put a minus sign, and then we put a in place of x, and that will be the answer. So there is one extra step that you do after the indefinite integration part is over, which is substituting these limits. Now what are a and b? A is the lower limit, b is the upper limit. You must have seen this in your physics chapters as well. So b being the upper limit is substituted first, and a being the lower limit will be substituted afterwards, and there will be a minus sign in between. Please understand that a and b need not be in an ascending order, meaning that b need not be necessarily be greater than a. It could be anyhow. It's the position where the b is and a is that defines whether that's a lower limit or the upper limit. So if b is written here over at the top and a is written below the integration sign and b is written above the integration sign, then a becomes the lower limit and b becomes the upper limit. Now let us solve some basic sums based on this concept. So let's see this first question. You have integration from 0 to 2 of 4x cube plus 3x square. Now the integration part is really easy. X cube you know is x raised to 4 by 4, x square you know is x cube by 3, and you get this 4 getting cancelled and 3 getting cancelled, and we write this lower limit and upper limit on the right side over here. Now let us substitute the upper limit in place of x. So let us put 2 in place of x everywhere. So x raised to 4 will become 2 raised to 4, x cube will become 2x cube. There's a minus sign in between. We'll close the bracket. Now we put a minus sign, and then we open another bracket, and now we put 0, the lower limit, in place of x. So you'll have 0 raised to 4 minus 0 cube, which is effectively 0. So that doesn't really count. So 2 raised to 4 is 16, 2 cube is 8, you get 16 minus 8, you get 8 as the answer. So please understand that in a definite integration sum, you will get a proper answer, a definite answer, which is also why it is called definite integration. So and in an indefinite integration sum, you may have maybe 2 or 3 methods to solve a particular sum. So you might get 3 different answers to those 3 different methods for that sum. But in definite integration, no matter which method you use in the by the indefinite integration method, eventually when you have integrated and when you then put upper limit and lower limit, you will get the same answer, whichever method you have used to solve that question. So let us see question number 2 now. Integration from 0 to 1, you have 3x cube minus 4x square plus 1 upon root x. Now these are really basic integration sums, the sums that we have done at the beginning of indefinite integration. So you will split up this root x across these signs. So you will have x cube upon x raised to half, which becomes x raised to 5 by 2, x square upon x raised to half becomes x raised to 3 by 2, and 1 upon x raised to half can also be written as 1 upon root x. Now let's integrate. So x raised to 5 by 2, the integration is 2 by 7 x raised to 7 by 2, x raised to 3 by 2, you have 2 by 5 x raised to 5 by 2, and 1 by root x you know is 2 root x. We've written this 1 and 0 on the right side, and now we'll substitute the upper limit, and then we will substitute the lower limit with a minus in between. So when we put 1 in place of x everywhere, remember 1 raised to anything is 1, so x raised to 7 by 2, x raised to 5 by 2, oh yeah, root x, so they are all going to become 1. So you will have a 3 2s are 6 by 7 into 1 minus 8 by 5 into 1 plus 2 into 1, and minus when you put 0 everywhere in place of x, they are all going to make it 0. So this is not even considered, that will just become 0. So what are we left with? We are left with 6 by 7 minus 8 by 5 plus 2. Now here is where your school level arithmetic comes in handy. You know the LCM of 7 and 5 is 35, so the LCM is 35. So you will multiply this 6 by what is not there under it, which is 5. So 5 7s is not, I mean it's 7, so there is no 5 here. So 5 6 are 30, minus 8 will get multiplied by 7 because there is no 7 under it, and plus We'll multiply the 2 by 35 because there is neither 5 nor 7 below it. So that will make it 2 into 35, 70. So 30 plus 70 is 100. 100 minus 56 is 44. The answer is 44 by 35. So some basic calculations will also be a bit of a challenge here. If your arithmetic is good, your trigonometry is good, that last part of these sums will not be a problem for you. Let us look at question number 3. I have integration of 0 to 2 x square minus 4 upon x square plus 4. So we will try to get the denominator in the numerator. So x square plus 4 minus 8. So we've expressed minus 4 as plus 4 minus 8. And then we will simply split this up across the minus sign. So x square plus 4 upon x square plus 4 becomes 1 minus 8 upon x square plus 2 square is what we can write x square plus 4 as under that. Now let's integrate. So integration of 1 is x minus 8 into 1 by a tan inverse of x by, so 1 by 2 tan inverse of x by 2. 2 and 0 have been written on the right side. Now we'll substitute the upper limit in place of x everywhere. So that will become 2 minus 4 tan inverse of 2 by 2 is 1. Minus, when you put 0, x will become 0 and you'll have 4 tan inverse of 0. Remember, tan inverse of 0 will be 0. So this entire bracket will be 0. So what is relevant is 2 minus 4 tan inverse of 1 for us. So 2 minus 4. What is tan inverse of 1? It is pi by 4. So 4 pi by 4, 4 will get cancelled. You will get 2 minus pi as your answer. Now come to question number 4. Let's come to some trigonometry now. So you have 0 to pi by 2. So the lower limit is 0, upper limit is pi by 2. Sin square x upon 1 plus cos x whole squared. So we'll write sin square x as the identity 1 minus cos square x. We'll write 1 minus cos square x as 1 minus cos x into 1 plus cos x. So 1 plus cos x will get cancelled with 1 of the 1 plus cos x whole squared. So now what you're left with is 1 minus cos x divided by 1 plus cos x. Now 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. 2 got cancelled. Sin square x by 2 upon cos square x by 2 is tan square x by 2. Again we'll have to use an identity. Tan square x by 2 is written as sec square x by 2 minus 1. Now we'll integrate. So sec square x by 2, the integration is tan x by 2 divided by half, which then becomes 2 tan x by 2 eventually, minus 1 integration is x. Now we'll put the upper limit and lower limit in place of x. So tan of, so you'll have 2 into tan of x by 2 में जब आप pi by 2 डालोगे, pi by 2 upon 2 will become pi by 4. So 2 tan pi by 4 is what you get there. Minus, in place of x you put pi by 2. Minus, then you put the upper limits, the lower limit, sorry, I beg your pardon. You'll put the lower limit. So minus 2 times tan 0 minus 0. You know tan 0 is 0. So this entire bracket is going to become 0. So that becomes irrelevant. What is relevant is 2 tan pi by 4 minus pi by 2. Out of which tan pi by 4 you know is 1. So that's 2 into 1. So that's 2 minus pi by 2. So your final answer is 2 minus pi by 2. Let's move to some other type of sums as well. Now look at this. Question number 5. You have 0 to 5 dx upon x square plus 2x plus 10. So this is the completing of squares type of sum. So let us complete squares. The half of 2 is 1, so we'll have to add 1, subtract 1, or we just split up the 10 as 1 plus 9. So x square plus 2x plus 1 becomes x plus 1 whole squared. I hope you remember this. You have to complete squares, meaning you have to take half of coefficient of x. So half of 2 is 1 and you square that, you get 1. So you have to add 1 and subtract 1. I hope you remember that. So x plus 1 whole squared is what you get, plus 9 is written as 3 square. So this is 1 upon x square plus a square type. So 1 by 3 tan inverse of x plus 1 upon 3 with a 5 and a 0 written on the right. Now we will put 5 in place of x first. So 5 plus 1, 6 by 3, you get 2. So you get tan inverse of 2. I've kept 1 by 3 out. Minus, then you put 0 in place of x. So you get tan inverse of 0 plus 1. So that's 1 by 3. So now you're left with 1 by 3 tan inverse of 2 minus tan inverse of 1 by 3. Now let's remember there is a formula in trigonometry. Tan inverse of a minus tan inverse of b is tan inverse of a minus b upon 1 plus ab. So I'm using that. So 1 by 3 outside, tan inverse of bracket 2 minus 1 by 3 divided by 1 plus 2 into 1 by 3. So what do we get? 3 2s are 6, 6 minus 1, 5. So you get 5 by 3 in the numerator. 1 plus 2 by 3 is 3 plus 2, 5 by 3. So you get tan inverse of 5 by 3 upon 5 by 3, which means this cancels. You get tan inverse of 1. What is tan inverse of 1? It's pi by 4. And there's a 1 by 3 outside which multiplies with pi by 4. And you get the answer is pi by 12. This is a very important sum. Okay, let's come to question number 6 now. Now in question number 6 we have a to 2a of integration a to 2a of dx upon root of 2ax minus x square. Again a bit of completing of squares will be done here as well. So a to 2a dx divided by root of, now we will make the coefficient of x square positive 1, so we'll take a minus common, so you get bracket x square minus 2x with a minus sign outside, the whole thing under the root. So half of minus 2a is minus a and square of that is a square, so we'll add a square and subtract a square. So we have added a square but actually we have subtracted a square in the bracket, so we will introduce a plus a square outside the bracket but everything inside the root. So what is this? So it's a to 2a dx upon root of a square minus, and this is x minus a whole square. Now this is your sine inverse of x by a formula, right? So this is sine inverse of x minus a upon a with a 2a and a written on the right over here, the upper limit and lower limit. So let's put the upper limit in place of x. So you'll get 2a minus a, which will become a upon a will become 1. So you'll get sine inverse of 1. Minus, when you put a in place of x, you'll get a minus a 0, 0 upon a 0, so you'll get sine inverse of 0. And so sine inverse of 1 you know is pi by 2, minus sine inverse of 0 is 0, so the answer will be pi by 2 minus 0, pi by 2. Now let's come to the last problem. Now question number 7, you have integration of minus 1 to 1 x tan inverse of x dx. So we have to apply the UV rule that we've learned in the indefinite integration chapter. Tan inverse of x, remember, is u, x is v, because tan inverse of x is inverse trigonometric function, x is an algebraic function, and so as per LIATE, I comes before a, inverse trigonometric comes before a in that order, comes ahead of algebraic, so therefore tan inverse of x will be taken as u and x will be taken as v. So we have tan inverse of x into integration of x, which is x square by 2, minus integration of, you have integration of x, which is x square by 2, into derivative of tan inverse of x, which is 1 upon 1 plus x square. So this is now to be integrated. Meanwhile we'll give a bracket and we'll write this upper limit and lower limit on the right side, and we'll continue writing it until this second part of the integration gets solved. Once everything is integrated, then we will substitute the upper limit and lower limit. So you have x square by 2 tan inverse of x minus this 1 by 2 is kept out. You have x square upon 1 plus x square. So we will try to get the denominator in the numerator. So we will add 1, right? We will add 1 and subtract 1. So you have 1 plus x square minus 1. You had x square, you introduced 1 and you subtracted 1. So you have this 1 plus x square upon 1 plus x square, which will get cancelled. You'll get 1 minus, you'll have 1 upon 1 plus x square on the side. So x square by 2 tan inverse of x minus, now 1, the integration is x, so you will get minus x by 2, minus half into this minus will become plus 1 by 2, and 1 upon 1 plus x square, the integration is tan inverse of x. Now I am just collecting the tan inverse of x terms together, so you'll have x square by 2 plus 1 by 2, so that is x square plus 1 the whole upon 2 into tan inverse of x minus x by 2. So that just makes it a little easier to substitute the upper limit and lower limit. So now let's put 1 in place of x everywhere. So 1 square plus 1 is 2, 2 by 2, tan inverse of 1 minus, you have 1 by 2. Put a minus sign and then start another bracket. Now we'll put the lower limit in place of x. So minus 1 square is 1, so that's 1 plus 1 upon 2, so that's 2 by 2 again. But this time it is tan inverse of minus 1, and minus of minus 1 by 2 will become plus 1 by 2. So you have tan inverse of 1, which is pi by 4, minus this 1 by 2, minus, then you have this bracket, and tan inverse of minus 1 is minus pi by 4, because tan of minus pi by 4 is minus 1. So you get minus pi by 4, and you have this plus half. But now when we apply this minus sign inside, this minus minus will become plus pi by 4, and this plus 1 by 2 will become minus 1 by 2. So pi by 4 plus pi by 4 will become pi by 2, minus half will become minus 1. That is the end of this sum. I hope these sums were clear to you. Until next time, goodbye.